First of all, a few disclaimers. This is my first DjangoCon, so I'm very happy to be here. Also, I'd like to give kudos to the folks who are transcribing these talks because they're having a hard time and they're pretty accurate at it. And they might not like me very much because I'll have to speak quite fast due to the time constraints. But here we go. So also, if you guys want to follow along this talk, this bit.ly link over there, bit.ly/DjangoCon19 has a blog post with the links for the presentations that all of us from Vinta are presenting here on DjangoCon. So here we go. As said, I'm going to be presenting a talk about pull requests, merging good practices into your project. And the single reason I chose to have this image over there is that next time you see a door that says pull, you remember it's a pull request. So here we go. I think I've kind of lost it here. Is it not working? Okay. As he's mentioned, my name is Luca. I'm a full stack developer. I have a master's in computer science. I work mostly with Django and React, maybe some other Python frameworks as well. I work at Vinta. Vinta is a team of experts from Brazil. We do development and consulting to build products the right way. And if you have any questions about development, if you want your project to be implemented or improved in some way, just reach out to us. There's our website over there if you want to check it out. So going to the content itself, I imagine that most, if not all of you, have already dealt in some way with pull requests. If you've heard about it, if you have to actually work on a pull request, and you probably have some ideas on how to do it. But I believe that for all of us, including me, of course, there's always ways to get better at it, and some simple things can take you a long way in that process. First of all, let's ask, why should we review code? But instead of asking me, let's ask the people. There's a good article called The Ultimate Guide to Code Reviews by Codacy, which I think is quite a bold title, by the way, in which they've surveyed 682 developers regarding several different things. And one of the things was, on average, what would they spend the most of their time on a daily basis? So they said that approximately half of the time, 51% of the time, they spent developing new features. And at the same time, they spent 70% of the time working on technical debt and 28% of the time working on bug fixing. So that amounts for 45% of their time, or almost the other half of their time. So they're half of the time working on new features, half of the time working on not new features. And that's because usually that can be improved with good processes in code review, in code management, fixing stuff before it breaks so you don't have to spend so much time on it. They were also asked what was the change in your development process that had the biggest impact to code quality. And of course, they've mentioned a ton of things like tools testing, automation, but the thing that stood out the most was code reviews. So even though usually you hear people saying that reviewing code is kind of boring, people still think it's very valuable and brings a lot of improvement to the process. They were also asked if they would review code before or after deploying the code to production. I know it's a weird question for some of us. Some people review the code after the deploying to production. Most of the people review it before. A weird amount of people review it like both after and before the deploy to production. And a similar number of people don't review code at all. And they're probably the ones responsible for this bug. I don't know if you guys are familiar with it. It was the iOS calculator bug where you sum up 1 + 2 + 3 and it would equal 24. So yeah. They probably didn't test it very much, didn't review the code. So the authors of that study came to a shocking conclusion that they found out that doing code reviews before the deployment was far more beneficial than not doing code reviews at all. So yeah, my shock, right? They also came to another conclusion, which is interesting, that doing code reviews both before and after the deployment was kind of the same thing as just reviewing it after the deployment. And the reason for that, according to them, is that when you're reviewing something that you know somebody else is going to review it after, you don't pay as much attention as you would if it was the only revision that you were doing that code. So for a few common errors regarding code review, Some people say that code review is a chore, or they say they don't review code at all because it's not important, or they don't have time for it, or just skip the code review for the deadline. And I noticed, like, I've been in the position of saying I'll skip the code review due to the deadline. I think maybe a lot of us have been, and it's very tempting, but you gotta remember that when you're reviewing code, you're not only improving the quality of the process and the project that you're working in, but you're also learning. You're learning new ways to implement things, you're learning new things about the language or framework you work with, and you're learning more about your project, maybe, areas of your project that you don't know yet. And also, while you're learning, you're also getting paid to learn. So it's like best of both worlds, right? And for some best practices here, I might go through them in a bit of a topic-based fashion. So forgive me if it's too quick, it's just due to the time constraints. One good practice regarding code reviews is having pull request templates. This is because we as human beings tend to be lazy, and our memory is very error-prone. So we can just trust ourselves or our colleagues to remember everything that we are supposed to fill out when creating a pull request. So having a template that says everything that the developer has to input in order for the reviewer to properly review it, it's very good. On GitHub, you can just create a pull request template file, markdown file on the root of your project. On GitLab, you just create a markdown file inside the .gitlab folder, and on Bitbucket, you can go in the settings and configure it there. You can also use a few other tips like status checks. Having status checks configured in your repository allows you to have a continuous integration server, for example, which is going to run your builds for every branch that you create. And it won't allow the branch to be actually merged into master or whatever your main branch is until it has passed certain status checks, like has it passed all the front-end and back-end tests, has it passed all the linters, etc. Adding guideline files as well is a great way to tell people how to contribute to your project. If it's an open source project, for example, and people don't know how should they, like they've made a fix and they don't know how to submit it, don't know how to create the pull request. Also, creating approval or merge rules. So as if someone is making a change in a specific file, you can have, for example, your repository configured in a way that unless someone else, some specific person approves that pull request, it cannot be merged for that specific file. So you can kind of protect specific files that are maybe too important for your project. You can also define push rules. For example, your pull request, the branch of the pull request must begin with a JIRA ticket number or something like that. So you keep everything organized. Another thing that's very interesting is Git flow. Maybe some of you are already familiar with it. Git flow is a consistent architecture that ensures that branches are always up to date. So the idea is that whenever you're going to build a new feature, you're going to branch off the master branch so that you're pulling from the most up-to-date code, and you're also not risking conflicts because everybody is pulling from that same branch. Git flow also suggests that you create a separate branch for each feature. So the point is, maybe you're working in a specific part of the project, like let's say a payment system of your product, and you're fixing something in the logic, and somebody says, oh, like the buy button in the payment system should be green instead of blue. And could you also make that change? And you say, okay, I'm already working on that section of the code, so I'll just change it. But if you do that, and maybe your main feature that you're working on gets like a lot of comments, a lot of change requests in the pull request, you're going to actually hold off that color change, which was a super small change that you could have deployed very quickly, until you actually finish the whole feature. So you're actually holding back features that could have been deployed super quickly. So I think a great way to think about this is to remember that branches are cheap, and they bring great flexibility. So you can just push something else that's super small, and it's going to bring great value while you work on stuff that's bigger and is going to require more time. Another great tip here is to look out for the PR size. So if you look at this, image right here, this is a PR with 71 files that have been changed. And well-defined issues, when you're creating the issues in your sprint, for your backlog, if you have well-defined issues, usually they're well broken down, they tend to generate smaller PRs. So that's something that's not just up to the developer who's doing the change, but also for the people who are actually managing how the issues are going to be distributed. So if you look at as I was mentioning, if you look at those 71 files, ain't nobody got time for that. So probably whoever's gonna review that, it's gonna have like a decrease in the review quality, because if you have like 5 files to review in a pull request, that's okay. You're gonna spend your time thoroughly. But if you have 71 files, you're probably just gonna go through them like diagonally and hope it's working fine. So you're gonna have a shorter attention span, and a shorter attention span usually equals more bugs. And now an analogy that I like to make is that pull requests are kind of like a kitchen sink. So I kind of need your input on this one now. If you look at these 2 images, which sink would you be more likely to put a new empty dish in? Like the full one or the empty one? Which one? The empty one? You would put the, well, that was not the answer I was expecting for, but okay. Oh, in my analogy, when you have something that's already full, you just think like, okay, just another dish, it's not gonna make any difference. But if you have this this clean, super nice looking sink, if you put an empty dish there, you're gonna be like, this is kind of, this is not good. I like my sink to be clean. So pull requests are kind of like that. If you start piling up pull requests that you got to review, you tend to just like, the more you get, you just don't care anymore. So an idea here is to make a habit. So maybe reserve a few days a few minutes of your day to review pull requests. So reasonably sized PRs usually shouldn't take much more than a few minutes of your day, like, I don't know, 30 minutes. And also, you could define days of the week to empty the queue. So for example, you can say that every Wednesday, no matter what, I'm going to empty all the PRs that are on my queue. I'm going to review all of them, even if it means that I'm just going to work on reviewing PRs the whole day. Because you got to also remember that maybe you're not in the mood for that, but the more you wait to review PRs, the more features are going to be delayed to be deployed to production. So you're actually holding back the project. Also, try to always write clear commit messages, so avoid the first one, the top one, which just says fixed PR comments, and write maybe a paragraph, which is going to take you like 30 seconds to write, and it makes it clear what were the changes you did. So maybe if you want to go back in time and revert back to some commit, you know where the change was made, what was done there, and it really helps in the overall organization. So remember to talk about how, and not just what you did. There's something here about positive and negative feedback. So here on the left side, for you guys, I think it's the right side. Maybe some of you have seen this. This is an answer from Linus Torvalds towards a guy who created a PR on, I think, for the Linux kernel. And Linus is not the most polite person. He's known for that, but especially here. And you got to remember, there's a human on the other side of the code review. And by the way, it's between quotation marks because it's the name of an article. If you guys want to read it, it's very nice. You should also remember that positive feedback doesn't mean to always agree with the person. You can disagree with the person giving a positive feedback. When you give positive feedback, people feel more inclined to expose ideas, and because they know that they won't be judged, they won't be like, they won't be judged, and it brings the idea of the fail fast way of thinking. So people are going to be more inclined to exposing their ideas. And their ideas are going to be put into trial. You're going to find the errors much sooner, or maybe find that the idea is not viable enough. And you're not going to spend as much time like working on it in order to like by the end of the project to find out that it doesn't work. So you just spend a lot of time and a lot of money in it. You just failed fast. And of course, if you provide positive feedback, it perpetuates positive behavior. So whoever receives that positive feedback is probably going to give positive feedback to other people as well. When working with pull requests, there's usually 2 main roles, which is being the author or the requester and the reviewer. As the author, I think the best idea here is to always describe the issue in the pull request, not just point to the card or ticket, because maybe sometimes you're just going to put in the description, oh, this fixes bug 3244. But the person who is reviewing that is going to have to click on that link, go to the issue, read the description, maybe read through a conversation, understand that maybe some of the requirements have changed, and maybe the person is going to review it and find something that he or she thinks it's wrong because the requirements actually changed throughout like some conversation. So if you just take some time to write what was the issue and what did you do, it makes everyone's life much easier. As a reviewer, remember to always ask questions. Don't make demands. So instead of just saying, fix that thing, why don't you say, like, shouldn't it be like this? So it's a much more polite and nicer way to say it. Also, don't say, like, why is this variable doing nothing? You could also say it instead, I don't see this variable being used. Maybe you should remove it, because sometimes it's something that you might not be seeing, that the person who wrote the code has already thought about that, and you give the person the opportunity to explain him or herself, and maybe it's something that you didn't catch it at first, but then you think, oh yeah, that actually makes sense. Remember that you are not a linter to give imperative instructions, nor you are talking to an AI assistant. You are a human being talking to another one, so you wouldn't like to be talked in a negative way, so try to remember that when you're reviewing someone else's code. Another good practice is having a minimum of X approvals. So of course it depends on the team size, but the idea is to avoid scenarios where you say, oh, I review your code, you review mine, we both approve each other's code, and that's okay, let's go home. I do have kind of a real life example of that. I used to work at a company that had geographically separated teams, and there was something happened with the folks at the other country, the team that was in the other country, where they would review their own code without passing it through us, which was not the kind of the policy that we had established. And every now and then, their code would come to us with bugs. So I don't know if the review process was not good enough, or they were just skipping the review, I don't know, but that would happen. It would also break the team unity. We would end up like amongst ourselves saying, oh, those guys, they always ship broken code. And it would create like a rivalry feeling between the teams, even though we were a single team. This practice also ensures that at least X+1 people know the code. So 1 being the person who wrote it, and X being the number of people who reviewed the code. So that's actually good for the management as well. So if the person who wrote the code is maybe on a sick day or something, someone else has some knowledge about the code, we can review it and fix a bug or something like that. Atlassian suggests that Atlassian suggests that you assign reviewers, like if you need like a minimum of 2 approvals, you assign 1.5 times 2, so 3 or 2.5, depending on the team size. So you can actually speed up how soon the pull request is going to be reviewed, because you're going to have more people assigned to it, so whoever is available is going to review that pull request sooner. Another tip is to always include screenshots on UI or UX changes. The cliche says it, a picture is worth 1,000 words. And also some changes are very small, some changes are like, you're in the context, you can see them very easily, but someone who's reviewing doesn't know, so they might not be obvious. Using git blame, usually we run git blame because we want to know who screwed up something in the code. But in this case, it's also very useful to finding out who you should assign to review your code. Maybe you're new to that code base, maybe you don't know exactly that part, and you don't know who to assign. If you do git blame, probably the person who appears the most is probably the person recommended to review that pull request. Also, let the automated tools do the nitpicky observations. So don't be that person who keeps saying, oh, you forgot the semicolon here, or you're writing camel case instead of snake case. Like, have a process in your team where you have linters, you have pre-commit routine that checks for that, so that you don't need to be the one doing it and being that annoying person that everybody hates. Remember to always teach and not just tell how to do things. So I'm going to show an example about that, but when you're like suggesting a change in someone else's PR, teach why that's wrong, why that should be done differently. Don't just tell, because otherwise the person won't actually learn. And when something breaks after code has been reviewed and deployed, remember to also share the fault, because it has gone through your eyes, even though you were not the one who wrote it, but you've reviewed it. So it's kind of your fault as well. We don't want to enforce the policy of pointing fingers at people, but the person who wrote the code is already going to be under pressure of being the author of that. So help the person with that as well. Quick tips about it. GitHub has some keywords feature. So if you write in a PR, for example, close pound 3244, it will actually close that issue when you merge the pull request. So you don't have to worry about managing your issues. You can also get permalinks to code snippets, so it's easier to reference when you're reviewing code or mentioning it to someone. There are some tools like Octohint, Refined Bitbucket, and Refined GitHub, which are browser extensions for you to have syntax highlighting, amongst other things, that help you reviewing code on those platforms, like you would see it in your text editor. Review apps from Heroku and deploy previews from Netlify are some tools that they allow you to actually deploy changes from a specific branch you've just created and are requesting the pull review to a public URL. So you can actually see your project running on the web, and maybe who's reviewing it can access that URL instead of having to run the project in their machine. So that's a very nice, obviously paid feature. And linters, as I've mentioned before, linters are very, very helpful for a number of things. If you access this talk, you click on these linters, that's actually a link for a talk by Flavio Juvenal. It's really great about linters. Some insights that we got from Vinta. Remember to warn people on Slack when things have changed the status on the pull request review thing. So if you've finished fixing the suggestions or you finished reviewing, alert the person on Slack instead of just relying on email or repository notifications, because some people sometimes check emails like twice a day, and it might take a few hours until the next check. And also remember to always test first the feature and then review the code. Because if you test the feature and you find out the feature is not working, it's not worth reviewing the code because it's probably going to change. Something is broken and the author is going to have to rewrite the code. So you're going to have to work twice if you actually review the code first. And finally, some real-world examples. They are mostly from the Django repository. I'm not sure if you can read it well from there, but it's basically someone sent a pull request to the Django repository. The person assigned to review it said, there's some conflicts. Please, can you resolve this first? So it's being as polite as possible. The author is not very used to the pull request flow. He doesn't know exactly how it works. And then the author very patiently explains something that maybe for some of us who are already experienced with pull requests would be like super obvious. He points out where he can find the conflicts in his code, like the arrow signs, the equal signs that divide what's the current one, what's the incoming change. So yeah, I've highlighted here. He says, can you please resolve the conflicts first? And then he says, at some point you must have pulled the rebase with master, so check for the signs. That's where the conflicts are. Another example here is when I was talking about teaching, not just telling. The reviewer is again saying, oh, are you still struggling with that? Maybe if it was in Python 2, the error could be this, but since it's Python 3, it's probably something else. So he's not just saying, oh, do it like this because it's the correct thing. He's actually telling how it should be done and why it should work like that, and a suggestion below. Here's just someone suggesting for the person to look at the guidelines of the project. So having guidelines is also important for people to actually know how to contribute to a project. And here's, I think, the last example. The reviewer suggested for someone to create a unit test for the changes they're making. The person didn't actually know how to do it. He kind of explained to the person where should the test live, because the person doesn't have the obligation of knowing how is the project configured. And also there's a second part of it that he comments, the reviewer comments in a specific part of the code, and instead of just saying this should be name, he says, do you mean name? If name in settings dict. So he gave the author the opportunity of explaining him or herself, and the author actually came with an explanation saying why he didn't think it should be like that. So maybe that's something you hadn't thought about before, and there's the opportunity for the author to explain. And finally, there's one more thing. We do at Vinta, we like checklists very much, and we've created a checklist for code review and management. It's not something that you review, you use it like for every pull request, but something that you might want to go through for establishing your code review and management process. So if you access this URL, bit.ly/pull request checklist, you can access it. The interesting thing is that it is cache-based, so if you select the options there are checkboxes, they stay selected for like next time you access it. It's open source, so if anyone wants to contribute, maybe add something, change something, find a typo or something like that, feel free, and it's free to use and share. And that's it. Thank you very much.
Thank you for that. That was very interesting. So I'm thinking of a scenario where you have like a senior developer who is overseeing the work of several junior developers, and the senior developer obviously reviews the code for the junior developers. But how do you have any advice for doing it the other way around when there's not necessarily as much oversight of the senior developer's work, and there might be like political conflict there? It might be a little bit weird.
Just so I'm clear, you mentioned about like the junior developer reviewing the senior developer's code. Is that it?
Possibly, yeah.
I think a good idea for that would be to have multiple people reviewing the code, maybe somebody who's a bit more experienced, and also having the junior developer review it so he can get the experience and actually learn the practices that he may be not familiar with. But I wouldn't suggest to have just a junior developer reviewing it. I would always suggest to have someone more experienced reviewing with him or her. I don't know if it answers your question. Yeah.
You always, all reviewers test the code.
I'm sorry, I'm not sure.
Here.
Oh, here, yeah, okay.
All the reviewers test the code, like you download it and test it. If, for example, you have to have two reviewers, the two reviewers download and test the code.
You mean like one person reviews, the other person tests the code?
No, if all the reviewers that are assigned to that pull request should download and test the code, because that's really time consuming. So
I'm not sure if I understood your question 100%. So you're like, are you asking about if if a same person should review and test the code? Is that it?
yes.
Oh, well, I think that's my personal opinion, of course. But I think that's worth it. Like it is time consuming, of course, but I think you gotta have an understanding of how the feature works in order to review the code properly. And you won't do it unless you actually test it manually, you do the QA. So I think it's worth it.
Okay, that's all the time we have. We have another talk in a couple minutes here. So thank you.